Okay, in this lesson, we're going to be talking about systems of function families. So again, we've been working with lots of different families or types of functions, and now we're going to be looking at a system of equations. If you remember the last time we spoke about system of equations, we know that a system means two or more, and usually in our case for Algebra 1, just means two. So our learning target says, I can find the solution to a system of equations by using my graphing calculator and looking for the point of intersection. If we remember, to intersect means to cross. So we will essentially be looking for where do our two functions have the same value? Where do they cross over each other? So we're going to start with a basic example of this in our Do Now question. We did back in Unit 4 systems of linear functions, and that's what we're going to review here. So the question says, what is the solution to the system of equations below? So we are given two functions here. Now we know first of all that in order to graph functions, we need them to be in the form y equals whatever else. So I see that our first equation is already in y equals, but our second equation is not. So in our second equation, if we want to get the y by itself, we would start by moving the 2x to the other side, and since it's positive, we would subtract 2x from both sides. On the right side here, 5 minus 2y, those are not like terms, so we would just leave it as 2x. So we would leave it as 5 minus 2x. So the two functions we're going to graph are y equals 4x minus 1 and y equals 5 minus 2x. So let's pull up our graphing calculator and graph these at the same time. So we'll start with our first function, y equals 4x minus 1. And then we'll get to our second function, which is y equals 5 minus 2x. Again, a system of equations means that we have two, so you'll notice that we have two graphs here. So zooming out here, we see that these intersect only one time. If we zoom in here and click on where we think that point is, this tells us that they intersect at 1, 3. So that means that the solution to this system is the point 1, 3. So sometimes our system will have one answer, sometimes it will have more than one, or sometimes no answers. So in this lesson, we're going to be back in our packet Function Families Part 3, but first we're going to be starting with a question in our Regents packet. So go into your Regents packet, find number 19, and let's get started. So there's two parts to this question. The first part here is asking us to graph f of x, which is the absolute value of x, and g of x, which is negative x squared plus 6. So let's start first by just making our y and our x-axes. They gave us a blank graph for whatever reason, so we're going to just draw in our axes so that we can graph. Okay, so starting with f of x equals the absolute value of x. Again, you should know what this graph looks like because we learned how to graph absolute value functions. But if you forgot, we'll come back into our graphing calculator. We hit our absolute value bars, and we're going to graph the absolute value of x. So remember, the absolute value of x is a V-shaped graph that goes through 0, 0. So let's go ahead and graph our function f of x. Okay, we'll go ahead and connect our points here. Again, the graph of an absolute value function is always a V shape, so we'll try to make these nice and straight. And then let's label this so we know which graph this was. This was f of x. Now let's jump over to our g of x function. We know right away that this is a parabola because we see that x squared. We also should know that our parabola is going to be upside down because our a value is negative 1. And we also know that the parabola has been shifted up 6 units because we see that plus 6. But yet, let's use our calculator to confirm what the graph should look like. So we'll type in y equals negative x squared plus 6. So we see that our graph looks like this. To pick out some key points that we should plot, we see that it goes through about 2.5, 0, both negative and positive. We see that our y value is up here at 0, 6. So let's go ahead and plot some of these points that we see on our graph. Again, the more points you plot, the more accurate your graph will be, which when we're answering Regents questions, especially, we want to make them as accurate as possible, and we will label this g of x. So we've now done the first part of the question. We graphed f of x, and we graphed g of x. Now let's get to the second part of the question here. It says, does f of negative 2 equal g of negative 2? We're going to answer this off to the side here. So does f of negative 2 equal g of negative 2? So let's think about what this means. We know that when we use our function notation, that when we put a number inside of the parentheses, that represents an x value, right? Like our f of x. So they're basically asking us here that when x is equal to negative 2, are these two functions equal to each other? So let's take a look. If we come over to our graph here at x equals negative 2, we notice here something interesting happening. Both graphs go through the point negative 2, comma 2. That was one of their points of intersection. So if we are asked the question, does f of negative 2 equal g of negative 2, we would say yes. So for the second part, we would say yes, f of negative 2 equals g of negative 2. And then it says use your graphs to explain why or why not. So we're going to say yes, f of negative 2 equals g of negative 2 because the graphs intersect at negative 2, comma 2. Which tells us that at the x value of negative 2, both graphs are equivalent to positive 2. So again, you're going to see in this lesson here that we're graphing a system, so two different functions at the same time. In this particular problem, we had an absolute value graph, and we had a quadratic graph, and then we went on to solve the following questions. For our guided practice, we're going to be back in our packet, Function Families Part 3. We're going to start on page 5, so go ahead and try the question at the top, and then come back to check your work. So our question here says, which value of x results in equal outputs? So we know that outputs are always our y values for j of x and b of x. So let's start by first graphing these two, and we're going to go ahead and graph them at the same time. So for j of x, we'll type in y equals 3x minus 2. And then for b of x, we'll use y equals, we hit our absolute value bar, and we want the absolute value of x plus 2. So if we zoom out here, we see our j of x in blue and our b of x in purple. And the question said, which value of x results in equal outputs? Well, if something has an equal output, that's basically where is their point of intersection. So in this graph, you should have noticed that these graphs intersect at 2, comma 4. So if we were to just sketch a picture of what we just saw, we saw first our j of x function was an absolute value graph that looks something like this. And we saw our b of x function was a graph that looked something like this. And we saw that they intersected at the point 2, comma 4. So to answer this question, which value of x resulted in the equal output? Well, we see that the value of x here was 2. So for our guided practice, we should choose answer choice 2. Okay, for our checkpoint question for today, here's your question. Please pause this video and then come back to check your work. So for this checkpoint, it should have felt very similar to you as our guided practice. Let's start again by graphing these at the same time. So for our h of x, we're going to graph 1/2 x plus 3. So we could always use 0.5. And for our j of x, we're going to graph the absolute value of x. So let's graph them at the same time. Okay, so noticing in our graph here, we see that they intersect in two different places. Our graphs intersect or cross at -2, 2 and at 6, 6. So we see again that they intersected at -2, 2, and they also intersected at 6, 6. So reading our question again, it says which value of x made the two functions equal to each other. So we would see that the two x values are -2 and 6, and the only one of those choices that we see here is answer choice 1. So in this question, again, you had a linear and an absolute value graph, and you saw where they intersected, which is where h of x equals j of x, and we should have chose answer choice 1. So for your independent practice, if you chose choice 1, you're going to start with green. If you chose answer choice 2, you're going to start with yellow because you were pretty close there. You just chose the wrong sign in your answer. And if you chose choice 3 or 4, or you weren't quite sure how to solve this problem, please try red. Everyone, no matter what group you're in, should notice that you can now answer number 4 in your Regents packet. So go ahead and take some time, go try these questions, and come back when you're ready to check your work. Okay, checking our work for our independent practice. Feel free to pause the video to check your work. Here's numbers 1 and 2 on page 5. Here's number 3 on page 6. Here's numbers 4 through 7 on page 6. Here's numbers 8 and 9 on page 7. And finally, here's number 10, also on page 7. So again, in this lesson, we were working with systems, meaning two equations of our different function families. We've learned about a couple different types of function families, and we were dealing with two at the same time. If you have any questions on this lesson, please come to Extra Help or shoot us an email. And to end this lesson, you should be able to answer question number 3 from your exit ticket, and you can also answer question number 3 from homework 9.3 as well.